What's up, guys? I wanted to make a really quick video to clear something up. There's a lot of contention and conjecture and speculation surrounding Kyley's knife, the APFK Mini. I got 3 knives. They're all roughly around the same sharpness, which is printer paper cutting sharp. And we have one with superb geometry, which is Kyley's knife. We have one with fairly good geometry, which is a very, very high, very lean hollow grind. And then we have one with what I call bad geometry, which is a thick flat grind with a fairly bulbous convex on the edge. Both these are convex. This is a V-edge with a very thin hollow grind. Just wanted to show you what good geometry looks like versus bad geometry, since so many people are speculating on this, and figured I could clear it up fairly easily. So I'm going to put as much force as I can into each one of these cuts just to show you. And this is pretty hard treated wood right here. As you can hear, it's hard as shit. So I'm going to take a clean portion, make sure this is in frame, which it is. Yep. Alright, and I'm gonna, that's about as hard as I could go right there. I'm gonna increase my angle of attack, in which case I don't even get into the wood. Yeah, it just doesn't bite into the wood. And if I decrease my angle of attack, then I just skip off the wood. Bad geometry, very bad, for wood cutting at least. This is dirty from cutting pumpkins, but this is a very, very lean grind. Near the edge, it's one of the thinnest knives I have, with a pretty shallow edge on it. I think it's like 30 degrees inclusive, so that should tell you how thin this edge is. I'm going to go ahead and try the same thing. I don't know if you can see, but I'm pushing so hard that the blood's coming out of my thumb. It just doesn't cut into it, period. I'll decrease my angle of attack a little bit, and then it just doesn't. If I take those little shavings off, then I increase the angle of attack, then it doesn't cut. It stops cutting. Take Kyley's knife. This is what I call good geometry. A very, very acute convex edge. Convex has the innate ability to separate material away from what it's cutting. That's why this is going to do what most people said it doesn't do. It cuts really well. I didn't even put that much pressure into that. It just bites into the wood extremely. Look how deep that is. I want to show the camera just how deep that really is. Look at that. That's a deep bite. A very deep bite. And I used maybe half the amount of pressure that I used on the other 2 cuts. I'm talking, this knife just bites into the wood. And as of right now, I would consider the knife fairly dull. I mean, it's not really dull at all, but by my standards, I would call this knife fairly dull right now. But, I mean, it just cuts. Look at that. Look at my finger. I hope you can see my finger. I'm not putting much force into this at all. That's 100% thumb force, and it's just peeling the wood back. Look at that. Now let's try this. It's taking little thin shavings off. Now the Azula. It's taking paper thin wafers off. This is big hearty chunks. And I'm putting much more force into these cuts. Just do it again. Look at that. That's pretty much irrefutable. I mean, it's, people seem to be not accepting my word when I say that the knife cuts well. So I just wanted to demonstrate the fact that it does cut well. There's no getting around the fact that these convex grinds just bite better. Look at that. It just cuts extremely well. And that's why on my rope cutting test, even though it didn't hold its edge long due to the cutting board, it still kept cutting. Look how deep those bites are. So that's what I wanted to make this video about. Hope I showed my point clearly. And thanks for watching, guys. I'll see you next time.